Hey there, gang. In this video, you're going to be looking at two formulas that you'll be using quite often in geometry. One is the distance formula, and the other is the midpoint formula. The distance formula is exactly what it sounds like. It's used to find the distance between 2 points. We'll call those points x1, y1, and x2, y2. And so the formula looks like this. D for distance equals the square root of the difference between the two x coordinates, so x2 minus x1 squared, plus the difference between the two y coordinates, y2 minus y1, also squared. That looks a little bit more complicated than it really is, I promise. So let's jump down to example 1 and see how this works. Example 1, we're given the graph with a line segment, and we're asked to find the distance between the 2 points on the graph. So let's start by labeling those 2 points. This first point on the left is -5, 3. And the second point on the bottom right is -2, -3. So we're finding the distance between -5, 3 and -2, -3. So the distance formula, which I do want you to practice rewriting each time so you can start learning and memorizing it, is distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Again, your x coordinates are -5 and -2. Your y coordinates are 3 and -3. It doesn't matter which one is x sub 2 and x sub 1. It doesn't matter which one is y sub 2, y sub 1, as long as you know which are the y's and which are the x's. So if you remember using the slope formula last year in Algebra 1, the process of plugging in these values is very similar to that. It's just you're using a different formula. Okay. So I'm going to go ahead and write out this formula with the signs that are already included. So my parentheses, my subtraction sign, and my exponent and square roots. And now let's plug in the actual numbers for the variables. So my two x coordinates again were -5 and -2. So we have -5 minus -2 here. And then the y coordinates were 3 and -3. So we have 3 minus -3 here. So let's simplify what we have. I have the square root still of -5 minus -2. That is -3 squared, so I still need my parentheses there, plus 3 minus -3 is 6 squared. Now anytime we square a negative, we get a positive, so -3 squared is actually positive 9. So this is 9 plus 6 squared, which is 36, and we get the square root of 45. So that's the distance between the 2 points. The square root of 45, if you know anything about perfect squares, you know that 45 is not a perfect square, so I can simplify that by using my calculator and typing in the square root of 45. I'm going to get a decimal, and we'll round that to the nearest tenth. So we're going to say that this is approximately 6.7 for the distance. Okay, let's try that again for number 2. This time they just give me the coordinates. A is -4, 1, and B is 3, -1. And they ask me to find the length of this line segment AB, which is the same thing as finding the distance. So I'm going to write out my formula. And then once I have that written out, I'm going to write it again without my variables, but set up everything else so that we don't mess up our signs. Okay, so let's look at our x values. We have -4 and 3, so this is -4 minus 3. And then our y values, we have 1 and -1, so 1 minus -1. Again, be careful with double negatives here. So let's simplify from here. -4 minus 3 is -7, so this is -7 squared, plus 1 minus -1 is 2, so this is 2 squared. -7 squared is 49, and 2 squared is 4, so I have the square root of 49 plus 4, which is the square root of 53. Again, 53 is not a perfect square, so I'm going to approximate my answer here. On my calculator, I get about 7.28, so I'll round this to 7.3. Approximately 7.3 is the length of line segment AB. Okay, so that's the distance formula. We also have a formula that's called the midpoint formula, and it's what it sounds like as well. If you're given, again, two coordinates, x1, y1, and x2, y2, this formula can help you find the midpoint of that segment, or the point directly in between those two coordinates. So the midpoint formula looks like this. The midpoint is itself a point, so this is an ordered pair formula. To get the coordinates of the x value of the midpoint, you simply average the two x coordinates you're given. So you take x1, you add x2, and then you divide by 2. And then the same thing for the y coordinate. Add the two y coordinates you're given, y1 and y2, and then divide by 2. So let's try this for number 3. You are supposed to find the midpoint of line segment GH, given that G has coordinates at 7, -5, and H has coordinates at 9, -1. So, again, write out your formula. Midpoint is x1 plus x2 over 2, and y1 plus y2 over 2. My x coordinates are 7 and 9, so I'm going to average those, 7 plus 9 divided by 2. And then my y coordinates are -5 and -1, so -5 plus -1 all over 2. 7 plus 9 is 16, so this is 16 over 2. -5 plus -1 is -6. So this is -6 over 2. 16 over 2 becomes 8, and -6 over 2 becomes -3. So my midpoint is 8, -3. All right, we're going to do the same thing for number 4. We're given that A has a point at has coordinates at -7, 4. And B has coordinates at 3, -4, and we want to find the midpoint of segment AB. So again, start with your formula. And so your x coordinates are -7 and 3, so this is -7 plus 3 all over 2. And then for the y coordinates, it's 4 and -4. So we have 4 plus -4 all over 2. -7 plus 3, that's -4. So this is -4 over 2. And then 4 plus -4 is 0, so this is 0 over 2. So we get coordinates of -2 and 0. All right, going to the back side. This time we're going to apply the midpoint formula to find a missing endpoint. So we're going to use the formula, but we're going to set problems up a little bit differently. So on number 5, this time they give me the midpoint. The midpoint I see is at -1, 2. And they give me one of the coordinates for one of the endpoints. They say that B is at 3, -5. But what I'm supposed to find is the coordinates of my other endpoint, which is A. So this problem is a little bit different than 3 and 4, even though we're still using the midpoint formula. So I'm going to start with my midpoint formula again. Okay, so I'm going to say midpoint is x sub 1 plus x sub 2 all over 2, and then y sub 1 plus y sub 2 all over 2. But the difference in this problem is I know what x sub 1 plus x sub 2 all over 2 is equal to. Okay, this entire fraction I know is going to be equal to -1 because I know that's the x coordinate of my midpoint. So I can say that this entire fraction is equal to -1. The same is true for my y fraction. I know this entire fraction is equal to 2, which is the y value of my midpoint. I also know one of the x coordinates and one of the y coordinates that go up here in this equation. So let me replace x sub 1 with the point I know. I know 3 is one of my x coordinates, and then let me do the same thing for y sub 1. I can replace that with -5 because I know that that is one of my y coordinates for my endpoint. So now I have this 3 plus x sub 2 all over 2 I know is equal to -1, and -5 plus y sub 2 all over 2 is equal to 2. So I can write two separate equations. I can say that 3 plus x sub 2, or I could even say just x all over 2 is equal to -1. And then I can write an equation with y's. -5 plus y all over 2 is equal to 2. Now let's solve each of these equations separately. For my first equation, I need to multiply both sides by 2. So that gives me 3 plus x equals -2. And then if I subtract 3 from both sides, I get x equals -5. For my second equation, multiply both sides by 2, and I get -5 plus y equals 4. And then add 5 to both sides, I get y equals 9. So this x value and this y value, -5, 9, are the missing two coordinates of point A. So A has coordinates at -5, 9. All right, let's do the same thing here for number 6, just changing the coordinates for you. So it tells me that K is the midpoint, and one of the endpoints is L, which is at -8, 6. So let me set up my midpoint formula. So I'm going to be missing an x value because I'm missing an endpoint and also missing a y value. But I know that one of the other x values is -8 and one of the other y values is 6. Okay, so always make sure your endpoint values are going here into your formula. -8, 6 is your endpoint. Your midpoint is -5, 10. So when we set up our equations, this fraction will be equal to -5, and this fraction will be equal to 10. So let's do that now. We have -8 plus x all over 2 equal to -5, and then 6 plus y all over 2 equal to 10. So top equation, multiply both sides by 2, you get -8 plus x equals -10. Add 8 and you get x equals -2. And then next equation, multiply both sides by 2, you get 6 plus y equals 20. Subtract 6 from both sides and you get y equals 14. So these are the coordinates of our missing point J, and that's going to be -2, 14. Okay, a couple more examples. This time we're going to use some algebra, well, even more algebra, to help us out. Number 7, it says if G is the midpoint of segment FH, FG is equal to 14x plus 25, and GH is equal to 73 minus 2x, find FH. That is a lot of information there. What's going to be very useful for you here is to draw a diagram. Okay, so we have a line segment FH, so let me draw that first. So line segment FH. Here's F, here's H, and the first thing they tell me is G is the midpoint of this line segment. So I'm going to put G right here. If G is the midpoint, then I also know these two smaller segments, FG and GH, are congruent. That's what it means to be a midpoint. It means that you are directly in the middle of a line segment, and so the two smaller line segments now are congruent to each other. It also tells me next that segment FG measures to be 14x plus 25. and segment GH measures to be 73 minus 2x. So if those two smaller line segments are congruent, I can just set these two expressions equal to each other and solve for x. 14x plus 25 is equal to 73 minus 2x. So let me add 2x to both sides. That gives me 16x plus 25 equals 73. Subtract 25 from both sides to get 16x equals 48, and then divide by 16 to get x equals 3. Now how does that help me? Well, it wants me to find FH, that's what the question's asking, find the length of segment FH, so that's the length of the entire segment here. Well, now that I know that x is 3, I know that FG is equal to 14 times 3 plus 25. So simplifying that down, I get 14 times 3 is 42 plus 25. FG is equal to 67. I also know that GH, because it's congruent to FG, GH is also going to be 67. So line segment FH is going to be 67 plus 67, which adds to be 134. So FH is equal to 134. All right, last example, number 8. Using the diagram to the left, if line N bisects segment QR, we're supposed to find QP. Remember, bisects means cuts directly in half, so that means that this segment QP is congruent to this segment PR, because line N is bisecting that segment. So again, I can set 3x plus 5 equal to 5x minus 19, just like I did in problem 7, and solve this for x. So subtracting 5x from both sides, I get negative 2x plus 5 equals negative 19. And then if I subtract 5, I get negative 2x equals negative 24, and x equals positive 12. I'm supposed to find the length of segment QP, so that's just this right here. So I'm going to plug 12 back into that expression, 3x plus 5. So this is 3 times 12 plus 5, and I get an answer of 41. All right, if you had any questions over this video, specifically the distance and midpoint problems, be sure those are written down so that you can ask those the next time you're in class. Until then, have a nice day. You're all wonderful people.